Assalamualaikum everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are focusing on this particular paper, which is paper 5, popularly known as S1, and it's of May-June 2021, variant 1. Now, let's look at the first question. The first question says, a bag contains 12 marbles, each of a different size. 8 of the marbles are red and 4 of the marbles are blue in color. How many different selections of 5 marbles contains at least 4 marbles of the same color? That means the possibility is when the word at least is used, at least 4, which means exactly 4, that is a possibility. Or it could also mean exactly 5. Because altogether we need 5 marbles. So therefore, one possibility is choose 4 red, 1 blue. Or 4 can be increased to 5. That is 5 red and 0 blue. That is a possibility. So the working is done right over here. It's a NCR question, combination question. That is 8C4 into 4C1. Let me just check the voice. I think it's all good, all clear. And this one is 8C5 into 4C0. So let me just highlight this. That is 8C4. This is 8C5. This is 4C1. This is 4C0. What about the other possibility? What about the option of selecting 4 blue and 1 red? Of course, that is possible. What about increasing 4 to 5? If I increase 4 to 5, that is not possible because the number of blue marbles are 4. How can you select 5 out of 4? So therefore, only one option is left. That is 8C1 and 4C4. So now add all of these together. That is 280 plus 8 plus 56. That adds up to 344. So for 4 mark, that's how it's to be done. That is an NCR question. That's the first one. Question number 2. Now let me remove this thing so that I can underline it right in front of you. Now the question says, a company produces a particular type of metal rod. The length of these rods are normally distributed. This is the mean. This is the SD, standard deviation. A random sample of 500 of these rods is chosen. How many? That is, they are asking for expected value, expectation. How many rods in this sample would you expect? They are re-emphasizing it again. To have a length which is within 0.5 centimeter of the mean length. Now, first of all, what we do in these questions is that we state the distribution. X follows normal distribution. What is X? That is the length of these type of rods. It follows a normal distribution, 25.2, 0.4 square, and 0.5 centimeter of the mean. That means if this is mu plus 0.5, mu minus 0.5. You can even work it with mu. Or you can use the actual value, which is 25.2, add 0.5, subtract 0.5. So now this is 24.7, this is 25.7. When we do the subtraction, this comes out to be 0.4, this comes out to be negative this comes out to be 0.5, this comes out to be negative 0.5. That was obvious. We divide it with standard deviation, and these are the 2 z values that we get. One is positive, one is negative. This is R7, rule number 7. If z lies between 2 values, such as one is positive, the other negative, take the normal distribution table, read the probability for this value, read the probability for this value, naturally discard the negative sign, add the probabilities, and then subtract 1. So that is how this is to be done. And this answer is coming out to be this. Now it's asking for expected value. So out of 1, This is 0.7888 out of 500. It's X. This is direct multiplication, cross multiplication, and you get this answer. Either round it down or round it up. Both are acceptable. Over here, what have I written? Technically, this is binomial. So y, another variable, follows a binomial distribution. There are 500 rods, and this is the probability of success, and this is the expected value, expectation. What have I written over here? If I did not have the access to this mu, so I can still work in terms of mu. This is mu plus 0.5, mu minus 0.5. This mu cancel, mu cancel. This is 0.5 over 0.4. This is negative 0.5 over 0.4. And this is still exactly the same thing as this. So that is question number 2, which has normal distribution and expectation is equals to NP. And that is part of binomial distribution. 2 questions are down. Let's move to the third question. Now it says, how many different arrangements are there of the 9 of the 8 letters of the word released? So we are talking about this word, which is RELEASED. We have RLASD, and we have 3 E's over here. So without any restriction, it's 8 factorial. Divide by 3 factorial. Why divide by 3 factorial? For the 3 E's. And use a calculator. You get this answer. The next one. How many different arrangements are there of the 8 letters in the word release in which the letters LED appear together in that order? You cannot change the order. So we have RASEE. 1 E is on the inside. Now this box is fixed. So this is 1. There is nothing happening. If this was not fixed, this would have been 3 factorial. 1, 2, 3, 4, 5, 6. The box is considered 1 unit. That is 6 factorial. Divide by 2 factorial for the 2 E's on the outside. So this is 120 divided by 2. This comes out to be 60. That is the answer for this particular part. All good, all clear? Now this thing is done. Let's move to the next page. There is also the arrangement thing. Now I would like you to first go through this. Just read the question, figure it out for yourself. What exactly are they asking for? So now over here, it says an arrangement of 8 letters of the word release is chosen at random. Find the probability. That means don't forget to divide by the denominator, which is 6720, which is answer of part A. So 6720, the answer of part A, that is already there. That becomes the denominator. Now it says the letters A and D are not together. That means these 2 letters are separated. So what do we have? We have RELESE. And then we have 7 spaces. Out of 7 spaces, we can fit in A and D. So this is for A and D. What about these 6? 1, 2, 3, 4, 5, 6. They can be arranged in 6 factorial ways. Divide by 3 factorial for the E's. That comes out to be 5040. This is the numerator. And we already have the denominator. So 5040 divided by 672. So I can write 504 divided by 672, and you can further simplify it if you want to. Now, let's focus on the alternative way because it's about 2 alphabets. There is also the possibility, first find A and D together. So if I find A and D together, that's 1, 2, 3, 4, 5, 6 plus the box, that is 7 factorial, divided by 3 factorial for the E's and 2 factorial, that is for inside the box. That is together. Without any restriction, answer of part A is 6720. 6720 minus together will give me not together. For 2 alphabets, not together is the same thing as not next to each other. Not together is separated. which is another way of saying not next to each other. And it gives us the exactly same answer, which is right over here. So now this question is also done. Question number 4. So let me just remove this thing, and then we can focus on this one. This is a probability question. So now let's focus on it. It's a big paragraph. Now, first of all, it says to gain a place at a science college, students first have to pass a written test, first have to pass a written test, and then a practical test. So it has to be in this order: first written, then practical. So this is first written and then practical. Each student is allowed a maximum of 2 attempts at the written test, and a student is only allowed a second attempt, only allowed a second attempt if they fail the first attempt. No student is allowed more than 1 attempt at the practical test. If a student fails both attempt at the written test, fails both attempt at written test, they cannot attempt the practical test. Now let's focus on the tree diagram. Ignore the values. Let's first focus on it. This is passing on the first attempt. This is failing on the first attempt. That's for the written test. If they pass, that's perfectly fine. If they fail, they can try the written test again. So pass and fail. If they fail, there is nothing ahead of them. If they pass the written test, whether on the first attempt, whether on the second attempt, then the possibility of practical test appears. All clear? Now let's look at the working. Let's look at the values. Now it says the probability that the student will pass the written test at the first attempt is 0.8. So that's right over here. If a student fails the first attempt at the written test, the probability they will pass at the second attempt is 0.6. That is over here. And the probability student will pass the practical test is always 0.3. That is over here. So it's a pretty basic thing. So 0.8, 0.2, then 0.6, 0.4. Then in front of this 0.3, 0.7, in front of this 0.3, 0.7. So very low probability of passing the practical test. Draw a tree diagram. That's done. Find the probability a randomly chosen student will succeed gaining place at the college. He passes on the first attempt, passes the practical test. So pass, 0.8 into 0.3. Fails at the first attempt, passes at the next attempt, passes the practical test. So this is 0.2, 0.6, 0.3. So this is pass. So this is pass written test, and this is pass practical test. This is fail written, pass written, and then pass practical. This is 0.3, this is 0.6, this is 0.2, this is 0.8, this is 0.3. All good. That's 0.276. Now let's read part C over here and then solve it on that page. Now it says that find the probability that the randomly chosen student passes the written test at the first attempt. What's the condition? Given that the student succeeds in gaining place at college. So the answer of part B, that becomes the condition of part C. So this is passing on the first attempt, 0.8 into 0.3. Failing written test, passing, and then passing 0.2, 0.6, 0.3. So that goes down. And then it says randomly chosen student passes the written test at the first attempt. So this is the working for the first attempt that goes up in the numerator. Something relevant out of the condition goes up in the numerator. That is the working. That simplifies to this. I think it is again pretty basic, a standard conditional probability question. Question number 5. It says the time taken by 200 players to solve a computer puzzle are summarized in the following table. There is time 0 till 10, 10 till 20, 20 till 40, 40 till 60, 60 till 100. And the number of players are given over there. Draw a histogram to represent this information. So now in a histogram, the very first thing that we look for, is it of equal class width or unequal class width? Now, first of all, what do you observe? You observe that it is of unequal class width. That is the first thing. So now, for unequal class width, we have to apply the concept of frequency density. So over here, what I've done is that first, make sure that this is already class boundaries. These are the class widths. So let me just erase class boundary over here. And let me just pick this thing up and write it over here. So this is class width. And the values are 10, 10, 20, 20, 40. Number of players, that is 16. This is the frequency. That means what do we need over here? So we need a column, a row for frequency density. So let me write over here, frequency density. What is the definition of FD? That is class frequency divided by class width. So 16 divided by 10, 1.6, 54 divided by 10, 5.4, 78 divided by 20, that is 3.9, 32 over 20, 1.6, 20 over 40, 0.5. So frequency density goes on the vertical axis and the class boundaries, they go on horizontal axis. And over here, this is frequency density. The first bar is drawn. Let me just draw it a little bit better. So, okay. So now we are starting with 0. And the highest frequency density is 5.4. That is why I have labeled it 6. And we choose a scale that is easier to read. One small box on the vertical axis is 0.1 unit. On the horizontal axis, we have to start from 0 all the way till 100. So this is 0, this is 10, 20, 30, 40, all the way till 100. So now over here, one small square is like 2 units. Okay, keep that in mind. So now if I draw the first one, 0 till 10, the frequency density is 1.6. So 0 till 10, the frequency density is 1.6. So this is 1.6. And that is how I'm drawing it. That is the first one. The first bar is drawn. The second bar is 10 till 20, height is 5.4. So 10 till 20, the height is 5.4. So, okay, for a second. Let's go all the way down. And keep in mind, I don't have a ruler. So that's how the second bar is drawn. Then we have 20 till 40, that is 3.9. 20 till 40, that is 3.9. That is the third one. Okay, so I've drawn 3 bars. You can draw the rest. All good, all clear? Now it says calculate estimates of mean time taken by these 3 of 200 players. Now this thing, I have basically copied it from there. So now the thing is, we have the mid value that we need. So let me write over here the mid value, that is x, the mid value of the class boundary. 0 and 10, the mid value is 5. 10 and 20, mid value is 15, and then 30, and then 50, and then 80. And this is the frequency, that is 16, 54, 78, 32, 20. X bar, that is sigma fx over sigma f. So multiply each value of x with its corresponding frequency. 5 into 16, 15 into 54, 30 into 78, 50 into 32, 80 into 20, divided by sum of frequencies, which is 200. Write down the answer to 4 significant figures, then round it off. They are interested in the value, which is the mean time. And this thing is made from before. That was the frequency density, which I did it over here. What else is there? Find the greatest possible value of interquartile range. Sometimes they can ask for the least, sometimes they can ask for the greatest. Now we know that there are 200 players over here. So 200 divided by 2 is 100. That will correspond to the median value. 25% of 200 is 50. That would correspond to the lower quartile. 3/4 or 75% of 200, that's 150. That will correspond to the upper quartile. Now the lower quartile, 16 plus 54, that is 60, 70. That means up till here, there are 16 people. Up till here, there are 17 people. So that means the 50th value would be somewhere over here in this, what you call the class boundary. So the lower quartile lies over here. Similarly, 16 plus 54, that is 70. 70 plus 78, that is 148. 148 plus 32, that means the 150th value would lie over here. So upper quartile lies between 40 and 60. Lower quartile lies between 10 and 20. Take the highest value, take the least value, upper bound, lower bound, the highest value. So that is 60 minus 10. That will give me 50. If they ask for the least, that would be 40 minus 20. That would be 20. That's how this particular part is done. Now let's look at question number 6. Let me read it first. The question says, in Questa, 60% of the adults travel to work by car. A random sample of 12 from this town is taken. Find the probability number who travel by work is less than 10. So we are taking 12. That's the number of trial. This is the probability of success. It follows a binomial distribution. Less than 10 does not include 10. So therefore, it's lesser than or equal to 9. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's too much to calculate. So what do? We calculate the probability of x greater than or equal to 10 and then subtract from 1. So we get the relevant answer. This is 12C10, success raised to power of 10, failure raised to power of 2. 12C11, success raised to power of 11, failure raised to power of 1. 12C12, success raised to power of 12, failure raised to power of 0. I wrote these 3 answers separately. You can also use a calculator, add up all these values, then write it down, then subtract from 1. Show every piece of working, assume nothing. This is the answer. Now it says a random sample of 150 adults from this town is taken. Use an approximation to find the probability that the number who travel to work by car is less than 81. So now number of trials is 150. Probability of success is the same. Probability of failure is the same as before. Calculate NP, calculate NQ. Since NP is greater than 5, NQ is greater than 5, that is the justification. Even if they don't ask for it, make a habit of writing it down. Because in S2, you will be using it a lot. And the examiner will be more than pleased to see elaborate working as taught on this channel. So now NP is 90, NPQ is 36. This is mean, this is variance, this is mean, this is variance. And it says less than 81. So don't forget continuity correction. This is 81, lower class boundary, upper class boundary. Less than 81 does not include 81. So therefore, choose this one number line, which starts from 80.5, which does not include 81. So probability X is lesser than 80.5. Probability Z is lesser than this value. And that is direct reading from normal distribution table. So a little bit of work is left for you to work out the decimal value. Probability Z is lesser than a negative value. 80.5 minus 90 divided by root 36 is negative, which is probability Z is greater than a positive value. And this is 1 minus 5 of this positive value. This is 1 minus this value from the table, subtract, and take care of the accuracy. Justify. They have asked it over here. I've already done it for 1 mark. Yes, some people ask this question. Should we write it again? Yes, write the value of NP, write the value of NQ. Since NP is greater than 5 and NQ is greater than 5, therefore the justification is that of normal approximation. Question number 7. Now, this one was a strong question. And let me explain it to you. And this was question number 7. So 2, 4, and I think I wrote it again. And then the rest of the working is over here. Okay. So now it says, let's first read this question. Let me just focus on this. Now it says, Sharma knows that she has 3 tins of carrots, 2 tins of peas, and 2 tins of sweet corn in her cupboard. All the tins are of the same shape and size, but the labels have all been removed. That means they are indistinguishable. You cannot differentiate between them. So Sharma does not know what each tin contains. Sharma is all confused. So now it says Sharma wants carrots for her meal. Sharma is a female. She wants carrots for her meal. And she starts opening the tins one at a time chosen randomly until she opens a tin of carrots. The random variable X is the number of tins she needs to open. 3 can, this is carrot, not car. 3 carrots, 2 peas, 2 sweet corn. Let me categorize them and into carrots versus the rest. So it's 3 versus 4. First of all, it's without replacement. It's not a geometric probability distribution because the reason is the replacement thing. That's why it's not geometric. Otherwise, if the probability was fixed, it could become geometric probability distribution. It would be geometric probability distribution because of the word until success is achieved. So the only way is to solve it using the probability method. Now, first part, show that x is equals to 3 is this for 2 marks, and then 4 marks for drawing the probability distribution table. So those people who study with me on a regular basis, they are aware of the fact when such a scenario comes, what do? I first focus on the main thing, that is draw up the probability distribution table. So first of all, what I'm doing is this. I'm getting a carrot, x is carrot, the random variable x. Let me highlight this. The random variable x is the number of tins that she needs to open. And the focus is on getting the carrot. So how many carrots are there? There are 3 carrots and 4 others. So what I do is that 3 out of 7, that's a simple thing. Just ignore this thing. Just focus on this. Probability x is equals to 2. This is 7. This becomes 6. It's one of the other things, other 4, and then you get a carrot. So you're getting carrot on the second attempt. Probability x is equals to 3. 4 is there. 4 becomes 3, and then 3 for carrots. The denominator is 765. Probability x is equals to 4. 7, 6, 5, 4. This is 4, 3, 2, and 3 for carrots. The ending is on carrot. Probability x is equals to 5. There were 4 cans of the rest. So you open each one of them, 4, 3, 2, 1. All those are used up, and then you end up with a carrot. Now, the answers over here, this is 3 over 7. This is 2 over 7. This is 6 over 35. This is 3 over 35. This is 1 over 35. Now, since they all have a denominator of 35, so what I did is that I converted 2 over 7 into something with a denominator of 35. So this is 7, this is 35, multiply by 5. So 2 into 5 is 10. This is 7, this is 35, multiply by 5, multiply by 5. Now, when you write it and you add it all up, they all add up to 1. That means this is a DRV scenario, a discrete random variable. These are integer values. And the sum of probabilities is 1. It's random. Everything has been taken care of. And out of this, I get this answer. Probability x is equals to 3. Probability x is equals to 3 is 6 over 35. So you automatically get the answer for the first part. You can rewrite it over here in the space. So all good, all clear? Now over here, find variance of x, that is Kaddish stuff. Expectation sigma px. Take x, multiply it with the corresponding probabilities, add it up. And now it's up to your acumen and your intellect that you can play around with this numerator, and then just divide once by the denominator, because I have taken care for this. So that is the tip and trick that you need to take care of, so that you can utilize your 1 hour 15 minutes wisely for your S1 paper. And you get expectation of x. Similarly, expectation of x square, px square. That means 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, 5 becomes 25. Now multiply it out this way. That is the working for this. And variance of x, that is expectation of x square minus square of expectation of x. And this is the final answer. So that is how this particular paper is done. That is of May, June 2021, variant 51. And that is the end of this particular session.